Hi everybody, today we're going to discuss linear functions. Let's start with a little bit of background of why would we do this and how does this really work in the real world. So I went on Statista, which is kind of my favorite site to go to get data, and I found the number of Starbucks stores by year from 2012 to 2021. That's a lot of data, so I took that and I made a little switch. Instead of the years being 2012, 2013, 2014 like that, I changed this over to be year 0, year 1, year 2, right? So I just kept going down for the years, and then I had Excel graph this for me. So as a graph, I did like a scatter plot. So you can see in year 0, we're at the 18,000. Over there, this year 9, we're getting close to 35,000. And with the little dots, you can really see that this looks pretty linear. I, in fact, had Excel do one more step and I had it add a trend line. So that means it came up with an equation that pretty much matches this line or this data. And it said the line that would best fit it would be 1,834.6 times x plus 17,918. What happens when you do this kind of trend line is it's not a perfect fit, right? So it has to make some adjustments to kind of come up with the line, but it kind of gives us an overall feel about what's going on. And overall, my feel is that I can see how many more stores we're getting a year. We're getting close to 1,800 more Starbucks each year, and that's from the year that I started. So I didn't go back to the beginning of Starbucks. I kind of just went to recent history, which is 2012. So this is our idea of what we want to start talking about in this section. So the first thing I want to do is give you a definition. A linear function can be written in the form f of x equals mx plus b. So we're still talking about lines, but instead of writing y equals, we're writing f of x equals, and you'll see we will bounce back and forth anyway. What m will represent here is the rate at which the function is changing. So it's still our slope, but we just think of it a little different as we think it as a change in the function. That m could be positive, so if it's going up like the Starbucks, or it could be negative, and we'll get that too. B is the initial value of the function, so it's our starting point. That's important as well, and I'll point that out as we go. So let's try that out. Let's take some examples to see if we really understand what's going on now. So I made this up, but I tried to base it on things we would care about. So from 2015 to 2021, the number f of followers to a celebrity Instagram account can be approximated by f of t is 1.25t plus 18, where t is the year, and t equals 0 corresponds to 2015. F of t is in millions, right? I don't want to write all those zeros, so I'm just telling you this is in millions. So A, we're going to start with how many followers did the celebrity have in 2015? So since t equals 0 corresponds to 2015, we can imagine 1.25 times 0 is 0, and we would just get 18. But I will write that in. F of 0 is 1.25 times 0 plus 18, which says that's 18. Now, when you write this as an answer, you want to make sure you show the millions. So we're going to write this as 18 million. We don't want to think we had 18 followers. No one would care about us if we have 18 followers. But if you have 18 million followers, that's substantial. That we care about. Then we're going to say, well, what is the slope of the graph of f? Well, remember, we're using this number in front of the t. So this is 1.25. Let's talk about what that represents. Well, this tells us how many more followers this celebrity is getting per year. So the celebrity is getting 1.25 million more followers a year. So the slope represents an increase of 1,250,000 followers a year. It's important that we think about that and really how big it is. So I wrote the number completely out, and I want to include the year to think, is that happening a day, a week, a month, right? We want to have that perspective. Back to what is the y-intercept of the graph? Well, the y-intercept of the graph is that beginning number of 18. So on the graph, because we're writing it as f of t is 1.25 t plus 18, the 18, not 18 million, would be the intercept. And what does the y-intercept of the graph represent? That represents the number of followers when time is 0. So we'll say initial number of followers. That doesn't mean at time 0, when they first signed up, they got 18 million in one day, which we know actually could happen, but it means in that first little beginning time. So maybe it took a day or two, but it's still that beginning followers. Or maybe they had been on Instagram for a while and it's when we started tracking. So you don't always have to think of 0 as 0 the same way we always have. All right, so another perspective, but we're still looking at lines. This one does extend past 0, not really realistic, but we'll go with it anyway. So it says the graph shows the number of subscribers to a local newspaper over several years. At what rate is the number of subscribers decreasing? So this is good. That way we have that perspective of things are going down, just like sometimes things go up, and we know newspaper sales aren't going really well lately. So let's take some points that we can see. So I can see this point at 0, 25,000. I can also see pretty clearly this one at 4, 15,000. So what are we calculating? We want to know the rate it's decreasing, so we're doing the slope. So I'm going to write the slope. So it's the change in y, so let's do 15,000 minus 25,000 over the change in x, that's 4 minus 0. So 15,000 minus 25,000, we have negative 10,000 over 4. And this says our slope is negative 2,500. What does that mean? We are losing 2,500 people a year, or 2,500 subscribers. Be careful with wording when you're answering this question. So it says, at what rate is the number of subscribers decreasing? You get to say 2,500. It's kind of a double negative if you say negative 2,500 when it already has the word decreasing. So careful of that. I don't want you to get something wrong because of just the wording there. So if it already says decreasing, you can write the positive 2,500. And so let's try another application. This time I have the cost of renting an electric bike is $2.50 plus 15 cents per mile. So I don't know if they have this all over the country, but where I live, you're walking in the city part and there'll be these electric bikes and electric scooters, and you kind of unlock them on the app and you can ride them for a little bit and leave them. So this is my thought here. So let's look through and see if we can figure out what's the slope. So $2.50 is the amount for like opening up the bike and like starting it. And then 15 cents per minute, that per really helps us to understand that's the slope. Per is like times x. So our slope is 0.15. The value of b says, well, what's the initial cost of just starting this bike? And that would be 2.50. And then if I want to make an overall cost function, which I definitely want to do, so we're going to call it c of x, where c will be cost, x will be minutes. It'll be 0.15 times x, there's that per coming in, plus 2.50. Let's use that. How much does it cost to rent the bike for 40 minutes? So this is c of 40. We're going to pay 0.15 times 40 plus 2.50. So this gives me altogether 0.15 times 40 plus 250, $8.50. So we can have this fun little ride on the electric bike, and it only costs us $8.50. So let's turn that into something else. Let's talk about a golf membership. So let's say we had like a country club kind of thing where they charge a membership of $5,000 to join, and then yearly you pay $2,750. So we're going to construct a function m of x that models the amount of money a member has spent x years after joining the club. So we'll start there, m of x. So there's this beginning $5,000 joining fee, so that's our b. And then this $2,750 a year, that's like each year, so we do 2,750x plus 5,000. Now we're going to find out what's the value of m of 5. So we say, okay, if we've been a member of this club for 5 years, then we paid $2,750 times 5 plus 5,000, which is $18,750. If we've been a member for 10 years, so we do $2,750 times 10 plus 5,000. Here, of course, I am assuming that the price stays the same. There's no increase in fees. That's probably very unlikely, but we're still going to use it, which says this is $32,500. Now, what I like and why I did these 2 years, 5 and 10, is to show you it did not double. 18,750 times 2 is not 32,500. Why is it different? Because you had a little initial amount you paid, and then you're paying per year. So it feels like you save money, right? It kind of feels like you didn't have to pay double for being there 10 years. It's 5 years, maybe a little trick to our head. So let's go back to thinking subscription services. So this table, again, I made these numbers up, but it shows the number of subscribers to a meal delivery service in thousands of customers by year. So in 2018, my made-up company had 11,000 customers. By 2019, it had 14,000. 2020 had 17,000, and 2021 had 20,000. So let's start with how many subscribers were there in 2019? Well, using our table, we can see that's 14,000. Make sure to add the thousands when they ask how many. How many new subscribers are there each year? Well, let's look at this. 11 went to 14, went to 17, went to 20. Because I could make these numbers up, I made it very consistent. 11 to 14, there's a difference of 3. 14 to 17, difference of 3. 17 to 20, difference of 3. So how many new subscribers each year? 3,000. So when we ask that bigger question, you throw the zeros in there. So we're going to find a linear equation s of x, where 2018 will be our x equals 1, and s of x will be in thousands. So this is a little tricky, but I did it this way because I see problems written this way, and I want to make sure you get it right. So what we need to know are two things, right? We need to know the slope, which we said is 3. Don't write the zeros there. And we need to know the b, which is the beginning time. Now, what you're not going to do is use B11 because that corresponds to 1. But what we could do is kind of use that to help us find the b. So if I'm thinking y equals mx plus b, right? That's my general form of a function or a linear equation. Then I could say, you know what? I know the slope m is equal to 3. I know that x is 1, right, in 2018. And whatever b is, when I put that together, I'm supposed to get 11. So I could solve for b. So I used this initial value to help me find the value of b. Well, luckily, this is nice. This says 11 equals 3 plus b. So move the 3 over, I get 8 is b. So now I found the b. So s of x will be equal to 3x plus 8. So I want you to think, go back and find b. Could you have just said 11 minus 3 is 8? Absolutely, that'd be a good way to do it too. So we're going to take this information and make a prediction, right? So we're going to say what happens in 2024. So we stopped at 2021. We want to go a little farther. A little bit what I want you to see is x equals 0 corresponds to 2017. 1 year before 2018. So my x here for 2024 minus 2017 is 7. That's what I need to plug in. So s of 7 is 3 times 7 plus 8. So that's 21 plus 8 is 29. So we're predicting 29,000 subscribers in 2024. Let's change our application a little. Let's talk about being a student and say that we had test scores of 85, 90, and 92. We're doing great. And we're going to take a final and it counts as 2 test scores. Or maybe this is all we have or just these tests. So we're going to come up with a linear equation that models the student's average score on the test, and that's all the tests. So the 3 tests and then this final. X is going to represent the score on the final. We're going to write this in terms of y this time. So we're going to say y is equal to, well, it's our test we had, 85, 90, and 92. And then this other one counts as 2. So we're going to do 2 times x. And then you have to think, well, what are you going to divide by? Well, you have 1, 2, 3, and this is 4, 5. So we want to divide by 5. So here's our start, as we have this nice little function. And then we're going to decide what grade do we need in order to average a 93. So let's go over here instead of y and say this is 93, and this is 85, and 90, and 92. And then whatever we do on the final, that's what we're trying to figure out, divide by 5. A nice first step is just go ahead and add up these numbers. That would give me 267 plus 2x over 5 is 93. Well, let's clear the fraction. Let's multiply by 5. So now I have 465 is 267 plus 2x. Let's move the 267 over. So now I have 198 is 2x. And let's divide by 2. And that says we need to get a 99 on this final if we want our average score for the class to be a 93. All right, another application we can talk about with lines is depreciation. They call this linear depreciation. Things don't always change as a line. There are other types of depreciation like exponential, but we're going to be real specific here and assume it's linear. So what depreciation is the loss of value of an item over time. And lots of things depreciate. So it could be cars, computers, business equipment, boats, right? So things that are just going down in value. So let's take an example I think we can all understand, which would be a smartphone. So say we bought a smartphone for $1,599 and we're just going to say we're committed to having it for 4 years. This 4 years is like what we would call our useful life of the equipment. So it's how long is it useful to us. So it doesn't matter when it goes down to the value of 0. That's not useful life. It's when do we no longer find it useful and we're like, we got to trade this in. We have our 4-year useful life, we decided. We also did a little research and we expect the trade-in or a salvage value of the phone at the end of the 4 years to be $575.64. I know that's pretty specific, but it'll make the math work. So we're going to start with what's the depreciation rate. So still think slope. We're thinking it was worth $1,599 and it's going to be worth $575.64, and it took 4 years for it to change in value. So this says it's depreciating by $255.84 a year. Yes, this is a negative amount, but we're already saying it's depreciating, so sometimes you can kind of go back and forth with the negative or not negative. But you'll see when we put it into the function, we will put the negative in. So we're going to express the value of the phone, and we're going to call it V, in terms of its age t. So V of t, the value at time t. So I go with it's depreciated at $255.84 per year, plus $1,599. Just to use this, let's say what's the value of the phone when time is equal to 2? So I'm going to put V of 2. I have negative 255.84 times 2 plus $1,599. This says in 2 years, the phone will be about $1,087.32 in value. This is our talk on linear functions. I hope you see how close it is to what we have done with lines. It's just really taking that m and saying, what does it represent? And it really is that rate of change. So what do we see year to year for m? Is it going up? Is it going down? And then always remembering to think about our units when we do an application. I hope that helps. Good luck.